Hello, everyone, welcome back to something new. In the previous video we have seen how a convolution layer work in convolutional neural network. We try to understand how does an image is being processed by convolution layer to generate feature maps. Now, let us understand pooling. So why do we even care about pooling? Because, whenever we try to create huge CNN models, they tend to be highly complex in nature in terms of calculations. In order to reduce this computational complexity, we go for pooling, which reduces the dimensionality of feature maps. Pooling downsamples the output of the convolutional layers by sliding a filter of some size with some stride size and calculating the maximum or average of values in filter. There are two versions of pooling: max pooling and average pooling. In max pooling, the output of the pooling operation is the maximum value of all the values that come under filter. In average pooling, the output of the pooling operation is the average value of all the values that come under filter. Let's take a look at max pooling. Consider this input, which is a 4x4 matrix of values. The pooling filter is of size 2x2 and his stride value equals 2. When we slide over the first 4 values, filter will take out the maximum value from the 4 values in input and considers it as the first value in the newly generated output. Like this, if we iterate over next values, we will get the output on the right. As you might have observed, the output size of the max pooling is exactly half the size of input. That's reduction in dimension, which pooling is all about. We will see this in real use case in some time. Now, average pooling does the same thing, except the values in the output are average of all the values that filter covers in input. There is also an extreme level pooling operation called global average pooling, which takes average of all the values in input and gives out a single average value as the output. Now we have an idea about pooling. Let's look at an example. This is an image of S character, which I made using Paint 3D. This image has 600 by 600 dimensions. When I try to apply max pooling on the feature maps generated by a CNN model, I got the following results. Image on left is a feature map and the right one is obtained after max pool operation on it. Look at them, you will find them similar in terms of clarity and feature. But right image has size exactly half of left image. Now let's look closer. You can see that edges are more sharp on the max pooled version. Max pool is most widely used pooling. Let's look at average pooling. Here, as you can see, the right image is much softer than the left image. Let's take a closer look. Now let's compare the two results of max pooling and average pooling. See, the difference is much clearer now. And also, you have to consider the point that both of the pooling methods have done a great job in keeping the features of the input image intact. This is all the images side by side with their dimension. Please have a look. This is a max pooled image with filter size of 10 by 10 and stride 2. Now let's understand the computational complexity which we were talking earlier. As for every model of deep learning, we get trainable parameter count, which is like a hint to the complexity of the model. For the current model, which I used for this demonstration, trainable parameters in non-max pooled version is 1,788,071, whereas trainable parameters in max pooled version is 894,111, which is exactly half the first one. This is the difference pooling is all about. In much bigger models, this impacts the performance a lot. Thank you for watching. See you in next video.